In the last video, we looked at two limits. We said that the limit as x goes to 0 of e to the x minus 1 over x is equal to 1, and the limit as x goes to 1 of the square root of x minus 1 over x minus 1 is equal to 1/2. Now we found these limits by just plugging in numbers really close to 0. And we found that when we plug in numbers close to 0, our function values are really close to 1. Here we plugged in numbers really close to 1 and found that these function values were really close to 1/2. So really though, what we have done is we've guessed these answers. We had intelligent guesses. We found a lot of data, and then we guess that this limit is 1 and this limit is 1/2. Well, we want to develop some rules for finding these limits without having to guess, or to show that this limit actually is 1 and this limit actually is 1/2. So we're going to look at some basic limit laws. But first of all, I want to look at two other very simple limits. First, suppose we want to find the limit as x goes to c of just a constant function, k. Our function's always k. As x gets close to c, our function values get close to, well, k, because it's always k. If we look at the graph here, say the graph of our function looks like this, and no matter what c is, as x gets close to c, our function values are getting close to k. One other, that's not really any harder. Limit as x goes to c of the function that's just equal to x. So in other words, here's the graph, y equal x. And as x gets close to c, what are the y values getting close to? Well, c, right? As x gets close to c, x gets close to c. Okay, so far now we have three limits that we know. And now we're going to look at some basic limit laws. This is from section 2.3. You ought to look at the textbook and follow along there. Okay, so assume that the limit as x goes to c of f of x and the limit as x goes to c of g of x both exist. Then our first limit law says this: 1. The limit as x goes to c of f of x plus g of x is equal to the limit as x goes to c of f of x plus the limit as x goes to c of g of x. Sometimes we read this by saying the limit of the sum is the sum of the limits. So for example, suppose we wanted to find the limit as x goes to 1 of the square root of x minus 1 over x minus 1 plus x. So here's a function. We want to find the limit as x gets close to 1. Now we could plug in numbers really close to 1 and see what values we get. Or we could use this limit law. So this says this is equal to the limit as x goes to 1 of the square root of x minus 1 over x minus 1 plus the limit as x goes to 1 of x. This guy is the limit that we looked at last time, 1/2. And as x goes to 1, x goes to 1. So this limit will be 1. We'll get 1/2 plus 1. The limit is 3/2. Okay, so there's our first limit law. Our second one is this. For any number k, the limit as x goes to c of k times f of x is equal to k times the limit as x goes to c of f of x. So for example, if we have the limit as x goes to 5 of 3x, okay, we have a constant times a function. We could pull that 3 out in front of the limit. Here we pull the k out in front of the limit. So this is 3 times the limit, x goes to 5 of x. This, of course, as x goes to 5, x goes to 5, so that's 5. 3 times 5, and our limit is 15. The third limit law is the limit as x goes to c of f of x times g of x is equal to the limit as x goes to c of f of x times the limit as x goes to c of g of x. So we summarize this sometimes by saying that the limit of a product is the product of the limits. So for example, if we look at the limit as x goes to c of x squared, well, this is x times x. So we say x times x, our f of x is just the function x, and g of x is just the function x. And so we can break that up into 2. This is the limit as x goes to c of x times the limit as x goes to c of x. Of course, we know that this is c. As x goes to c, x goes to c. So this will be c times c, or c squared. So looking back, this perhaps was kind of obvious. As x goes to c, x squared is going to c squared. What if we had the limit as x goes to c of x cubed? Well, we would think that this would be c cubed. And in fact, we can show that's the case because this is the limit as x goes to c of x times x squared. We can use our third limit law. The limit of the product is the product of the limits. So the limit as x goes to c of x times the limit as x goes to c of x squared. We know that this limit is c. We showed that the limit as x goes to c of x squared is x squared, c squared, excuse me. So this limit will be c times c squared, or c cubed. And of course, you can see that we can continue like this and find that the limit as x goes to c of x to the n is c to the n for any n equal 1, 2, 3, etc. We've already shown it for 1, 2, and 3, actually, but we could continue on. It's also true for n equal 4, or 5, or 6. Now, notice that from limit law 3, that the limit as x goes to c of k times x squared is, we pull the k outside, the limit of x squared, I'm sorry, let's make this x to the n. So it'll be k times c to the n. Also, from limit law 1, the limit as x goes to c of ax squared plus bx plus, some constant, let's say p. I don't want to use c because we're using c here. Well, that's going to be the limit as x goes to c of ax squared plus the limit as x goes to c of bx plus the limit as x goes to c of p. And up here, we know that the limit as x goes to c of k times x to the n is just k times c to the n. So this will be a times c squared. This will be b times c. And the limit of a constant, remember, that's limit, well, that's our one of the very first limits we looked at, will just be p. And if we compare what we started with what we ended with, you can see that finding this limit as x goes to c, we just get the same polynomial with c plugged in to the polynomial. And we could see this would happen no matter what our polynomial was. As long, if we had 20x to the fifth plus 7x squared minus 2x, etc. We could evaluate it, the limit, just by plugging the c in. So in fact, that brings us to a theorem. If p of x is a polynomial, then the limit as x goes to c of p of x equals p of c. Here, let's illustrate what we mean here. The limit as x goes to 3 of 4x cubed minus 2x squared plus 5. This is a polynomial. Remember, polynomials are just sums of terms that look like ax to the n, ax to the n, where n, these exponents have to be natural numbers, whole numbers, 1, 2, 3, 4, etc. Okay, well, according to this rule, all we have to do is plug 3 into our polynomial. 4 times 3 cubed minus 2 times 3 squared plus 5. That turns out to be 108. You could check this with your calculator. 18 plus 5 is 95.